Welcome back. What we're talking about today is adding and subtracting rational expressions. So in the last two lessons, what we've been looking at is simplifying rational expressions by factoring and eliminating factors that match up on the top and bottom, multiplying and dividing rational expressions, and today we're getting the final little piece of the puzzle here is adding and subtracting rational expressions. This is the last way that we are going to combine these rational expressions. Adding and subtracting fractions does require a little bit more. When you add or subtract a fraction, if you think back to your fourth or fifth grade, third grade, whatever grade it was that you did this, you can remember that what you did was, as long as they had a common denominator, if they had the same thing on the bottom, then you could add 1/12 plus 7/12 equals 8/12, and then you could simplify by dividing by the same thing. Would give you 2 over 3. The same thing here, 2 over 5p minus 7 over 5p, the same denominator, means we could subtract 2 minus 7 is negative 5, and then we could simplify. In the same way, these rational expressions that we're going to be adding or subtracting, we hope that they have the same denominator. When they do have the same denominator, notice that when we add them, the denominator remains the same. You just add across the top or subtract across the top and keep the denominator. If they don't have the same denominator, then we're going to have to get them to have the same denominator. It's called a common denominator. And what we're going to look for specifically is the least common denominator. All right, here's another couple of examples. Same type of idea. They have the same denominator, so we know our answer is going to have the same denominator. And when I add across the top, I get 2 plus 7d. Just a different looking answer, but nothing different that actually happened here. Same thing on the bottom. I'll have x squared. This minus is actually going to this entire fraction. So minus negative 5x would be plus 5x minus 24 over x minus 3. And with these problems, you always want to make sure that you're done. One way to know that you're done is to see, can I actually factor this top and maybe have something that I could eliminate? In this case, I think we could have 8 and 3 multiplied to 5. I believe this is going to factor to 8x plus 8 and x minus 3. If you need to go back and brush up on those factoring methods, you can go back and watch the series that I did on factoring. And now that we have the same things on top and bottom, we can divide those away and just be left with x plus 8. When you get to the end of any problem, you should look at it and think, can I do one more step? Can I simplify it one more way? And a lot of times with these, the way that you're going to simplify them is by factoring and then eliminating one of those factors from the top and bottom. We'll see that as a theme today as we go. We'll see more and more of that. All right, when we talk about the least common denominator, a common denominator is things that we can multiply to get, right? So, for example, the least common multiple is between 20 and 8, the smallest thing that we can multiply both of those to get. Notice that they both have a 2, one of them has a 5. What we're going to do is look for what they already have in common. And what we're going to do each time is we're going to sort of make this little box over here. So notice that we factored them. We've got the prime factorization. Step 1 is to factor them. Step 2 is to find all of the unique primes. We want a list of all of the unique primes. So for example, what would I need to have this? I would need a 2, a 5. What am I lacking to have 2 to the third? I need another 2, right? So 2 times 2 times 2 times 5 is 40. Notice I can multiply 20 to get 40, and I can multiply 8 to get 40. And in fact, 40 is the least number that I can multiply both of them to get. It's the smallest number that both of them will multiply to get, the least common multiple. We'll see some more examples of that. So here, what we'll do is, each time we're going to make a little box that says LCD, and we're going to fill that box. So here, 5 over 14, I care about the denominator. 14 is 7 times 2. So I know I need a 2. I know I need a 7. These things are multiplied. 49 is 7 times 7. So what am I lacking here? I'm lacking another 7. So now the first denominator is represented and the second denominator is represented. That 8, if I broke it down into prime factors, is 2 times 2 times 2. So I actually need another 2 and another 2. So now my least common denominator is whatever 2 times 2 times 2 times 7 times 7. We can pull out our calculator and see that that is 392 is the least common denominator. All right, same thing applies when you have rational expressions with variables. That's okay. This right here, again, I'm going to make my little box over here, LCD, and I'm going to try and fill that box with all the things that I need. This is the same thing as 3x, x, z. So I know I need a 3, I know I need an x and an x, I know I need a z. This is the same thing as 5 x's and 3 y's. So I need more x's, 1, 2, 3, 4, 5. And I also need 3 y's, 1, 2, 3. And so my least common denominator here is 3, x to the 5th, y to the 3rd, z. That's everything that's in the box. Let's try to find, again, some least common denominators. I'll do this first one with you. So first, a squared minus 25. I'll make my little box, LCD. A squared minus 25, that's the same thing as a minus 5, a plus 5. For right now, I don't care what's on the top. The second fraction, so I know I need a minus 5. I know I need a plus 5. The second fraction there is 2, a minus 5, when I factor it. So I know I need a 2, and I know I need a minus 5, which is already in the box. I don't need another. So my least common denominator is all of those things together, 2, a minus 5, and a plus 5. We're not going to distribute those, and you'll see why in a second. We're going to need each of those pieces. Try the second one. I'm going to show you what I did in about 3 seconds. So this is what those denominators look like factored, x and x minus 2 and x minus 2. So if I make a box, try and put everything in there, I definitely need an x, I definitely need an x minus 2, and here I have an x minus 2, I need another x minus 2. So my least common denominator is x, x minus 2, and x minus 2. So when we actually go to add them, what we're going to do is we're going to find the LCD just like we have been. We're going to factor, we're going to make a box, identify what the LCD is, and then we're going to multiply by whatever's missing. Let me show you what I mean. So this is the same thing as 5 times 2. So my LCD, I definitely need a 2. I definitely need a 5. This is the same thing as 5 times y. There's already a y in that box. I definitely need a y in the box. So now, is everything represented? 2 and 5? Check. 5 and y? Check. All right, so what we're going to do now is look at what is missing from each of those fractions. So 1/10 that has a 5 and a 2, it's missing a y. So I need to multiply here by y over y. The second fraction has a 5 and a y. It's missing a 2. So I need to multiply by 2 over 2. And watch what happens when I do that. The first fraction, y times 1 is y over 10y. The second fraction, 12 times 2, is 24 over 10y. And now I went from a problem that did not have common denominators to a problem that does have common denominators. Now I can add my two fractions. That's the same thing as y plus 24. Remember, we just add across the top. As long as they have the same thing on bottom, we can add them together. They have to have a common denominator to be able to add the fractions. So step by step, here's what we did. We factored the denominators. We found the LCD. We multiplied by what was missing so that we would have a common denominator. And then we added across the top while maintaining the denominator. Remember the last step here, simplify. If you can factor the top or factor the bottom and see if there's something you can eliminate, then absolutely do it. Here the top is prime, so there's no way to factor it. We don't have anything that matches top to bottom. All right, here's another, very similar. LCD, what are we going to have in this LCD? This is the same thing as 7 and k, so I know I'll have a 7. I know I'll have a k. This is the same thing as k and k, so I need another k. So the question is this denominator represented? Yep, there's a 7 and a k. Is this denominator represented? Yep, there's a k and a k. What am I missing here? 7k, 7k. I need another k. So I'm going to multiply this fraction by k over k. What am I missing here? I have a k and a k. I'm missing a 7. You see that? So I'm going to multiply by 7 over 7. And what we have after we do that is 4k. I'm just multiplying this stuff. 4k over 7k squared. keep my minus sign. Now I'm going to multiply this stuff, 21 over 7k squared. And now notice that the denominators are the same. So now we can subtract across the top, 4k minus 21, which is prime, over 7k squared. We have one fraction. We did our subtraction and combined into a single rational expression. Let's keep rolling here. Here's another. I would like for you to try this. Pause the video and see if you could try this. I should have hidden the LCD. So the first denominator is just 3 and x. The second denominator is 2x and x. So the LCD is a 2, a 3, a x, and an x. So look at it and see what's missing from the first fraction. I multiplied the first fraction by 2x and 2x. The second fraction by 3 over 3. When you multiply across the top and multiply across the bottom, you get 8x over 6x squared minus 3 over 6x squared. Then, since they have the same denominator, you can add across the top. Keep the denominator the same. Since the top is prime, there's no way to simplify. All right, same thing here. The LCD, the first denominator is just a 3. The second denominator is just a 2, and that's all there is. That's okay. So what we're going to do is multiply this one by 2 over 2, and this one by 3 over 3. When we have a binomial on the top, we do have to be sure to distribute into that, and we need to be very careful with that subtraction symbol. So this is the same thing as 4q minus 4 over 6, keep my minus sign, 3q plus 3 over 6. I distributed on each of these, I distributed in. All right, now, since they have the same denominator, I can subtract across the top. Again, that subtraction, I'm subtracting each of those things. It's like I'm distributing a minus sign. So 4q minus 3q is just q. Negative 4 minus 3 is negative 7. All over 6, because 6 was my common denominator. That's my answer. I think the most confusing part of this is that this subtraction sign, if you want to distribute it to both, you can do that. That may make it easier for you to look at. But the subtraction has to go to everything in that second fraction. Here's another. Let's find our LCD. First denominator is prime. We can't do anything with it. So there's definitely an x minus 5 over here. The second denominator is x minus 5 and x plus 5. So I need another x plus 5. Notice that the first denominator is represented, second denominator is represented. What am I missing over here? Missing an x plus 5. What am I missing over here? I seem to be missing nothing, so I'm not going to multiply by anything over here. It's already got everything that it needs. That's perfectly fine. So now when I distribute, on the left side I'll have x plus 5 over x plus 5, x minus 5. I don't like to distribute at this point because I don't want to have to factor again. You know, when we get to the next step, we're going to have to factor again to see if anything matches up. So x plus 5 plus negative 10 gives me x minus 5. And remember, step 5 from those steps says if you can simplify, do so. There's an x minus 5 on top and bottom. That leaves you with just a 1 on top. So 1 over x plus 5 is my solution. Ooh, this is a toughie. All right, take a second. First step that we're going to do is try and factor in any denominators we can. The first denominator is prime. The second denominator is prime. The third denominator factors into p minus 1 and p plus 6. And so we'll have an LCD of p minus 1 and p plus 6. I'm going to multiply the first fraction by p plus 6, top and bottom, because that's what it's lacking from this box. The second fraction I'm going to multiply by p minus 1, top and bottom, because that's what it's lacking from this box. The third fraction I'm not going to multiply by anything because it already has everything from the box. Now distribute. Notice that I kept the negative signs. all those negative signs carried down with the problem. We can actually perform that distribution. And I went ahead and combined everything into one fraction since they all have the same denominator. We have a lot of like terms here that we can combine. Notice on the top, remember step 5 is to simplify. The top looks like it can factor into p times p plus 6. And now there's a p plus 6 top and bottom. So all we're left with is p over p minus 1. That's the toughest one we've done so far. And the last question here, this is the trick that we keep coming back to, where it seems like the bottoms are almost the same, and without having to do a whole lot of work, we could do a LCD, do d minus 7 and 7 minus d, or we could realize that this is the same thing as taking a negative 1 out. Remember, if you divide negative 1 times 7 minus d, that's the same thing as positive d minus 7. Remember, if we distribute that, we've seen that as a theme here for the last several lessons. To get the opposite order of a difference of two items, we could factor out a negative. All right, 1 minus 5 is negative 4. And that's our answer. That was the easy way. Now, you could have gone through and distributed. You would have just ended up with some things that you had to factor at the end and simplify. You could have said your LCD was d minus 7 and 7 minus d, multiplied all the things together, and combined like terms. You just would have had things, like I said, at the end that would have simplified. This brings us sort of to the end of our rational expressions. We may have a lesson on rational equations. The next topic that we're going to look at is roots, square roots, cube roots, and things like that.